Class 9 Number Systems Module 3 Objectives. In this module, you will learn about real numbers and their decimal expansion. Dear students, last class we had discussed some points of real numbers and their decimal expansion. Once again, I am repeating it. Listen carefully the examples. What do you mean by real numbers? Yes, a collection of rational and irrational numbers are called real numbers. From that, the first example, find the decimal expansion of 10 by 3, 7 by 8 and 1 by 7. Yes, these are what? Rational numbers. Now, when we divide these rational numbers, listen the first one example, 10 by 3. So, 3 times 9, balance 1. Then put 0 decimal point. After that 3 times 9 etc. repeating that 1. Then second case 7 by 8. So in that case 0.875 is the quotient. At last what is the remainder? Yes, the remainder becomes 0. Then the last case 1 by 7. The quotient is what? 0.142857 etc. That means 142857 is repeating. Then there the remainders listen. First case 1 time 7 balance 3. Then 30 put a decimal 30 28 then 2. So listen, in all these cases the first case remainders are 1, 1, 1, 1, etc. Divisor what? 3. Second case remainders 6, 4, 0. Then the divisor what? 8. Then the next one, the remainders are first case 10 minus 7, 3. Then 30 minus 28, 2, etc. That is 3, 2, 6, 4, 5, 1. Then that same one repeating 3, 2, 6, 4, 5, 1, etc. There the divisor what? 7. Now from this division we can conclude some points. The first point what? The remainders either become 0 after a certain stage or start repeating themselves. So listen carefully in the second question, 7 by 8. At last the remainder is what? 0. Then the quotient was 0.875. The division stops there. Now the other first case and the last case, there the quotient is what? 3.333 etc. and second 0.142857 etc. They are repeating. Now the second point, listen. The number of entries in the repeating string of remainders is less than the divisor. Listen that small box. The remainders are 1, 1, 1, 1, etc. Divisor is 3. So the remainders are less than the divisor. Second case 640 less than the divisor 8. Then 3, 2, 6, 4, 5, 1. Then that remainders are also what? Less than the divisor. Now next one, if the remainders repeat, then we get a repeating block of digits in the quotient. So if the remainders are what? Repeat. Remainders are repeat, then the quotient what? 3.333 etc. The quotient also what? Repeat. Okay, repeating number of digits. The last case also what? 0.142857. Then also what? 0.142857 etc. is there. It is a repeating block of digits. Then the two cases from these examples we can conclude two cases. The first case the remainder becomes 0. The example 7 by 8 the remainder becomes 0. In the example 7 by 8 we found that the remainder becomes 0 after some steps, and the decimal expansion of 7 by 8 is what? 0.875. The division stops there. No repeating dots are there. Other examples 1 by 2, 0.5. When you divide 1 by 2, what is that? 0.5 is the quotient. Then the second example also. No need of taking. So listen carefully. In these two examples, the division stops after some places of decimal. Okay. So such a type of rational numbers are called terminating rational number. So listen, that case the decimal expansion terminates or ends. Another word is what? Ends. After a finite number of steps. We call the decimal expansion of such numbers are terminating rational number. Terminating. Then the second example 7 by 8 is what? 7 by 8 is a terminating a rational number. First case of rational number. Then second type of rational number. The remainder never becomes 0. The example 10 by 3 and 1 by 7 etc. We notice that the remainders repeat after a certain stage, forcing the decimal expansion to go on forever. In other words, we have a repeating block of digits in the quotient. That is first one about 3.333 etc. Then 1 by 7, 0.142857, 142857, 142857 etc. is there. That is what a repeating. So such a type of repeating quotients are called what? Such a type of decimal form are what? Non-terminating recurring. Recurring means what? Repeating. Okay. So the second type of rational number is what? Non-terminating repeating decimal numbers. Then the usual way of showing that 3 repeats in the quotient of 10 by 3 is to write it as 3.3 bar. So the number 3, the decimal part is repeating. So write 1 3 and put a bar in the top of that. Okay. Now the problems. Listen carefully. Show that 3.142678 is a rational number. In other words, express this in the form of P by Q, where P and Q are integers and Q not equal to 0. So listen, we need to show this number 3.142678 is a rational number. So we know the definition of rational number. What is that? Yes, the numbers which can be written in the form P by Q. So a simple one is this. 3.142678 is equal to how many decimal places there? 1, 2, 3, 4, 5, 6. So avoid that decimal and write all that numbers. 31,42,678 divided by how many zeros there? 6 zeros are there. That is 10 lakh. Now it is in the form but P by Q. So it is a rational number. Okay. Now this one is simple one. Now next type of questions are very, very important. So rational numbers are two types. One is terminating. So terminating rational number example is this one. Now the second one is what? Non-terminating and repeating. Terminating means ends, okay, or stops. Non-terminating repeating means the first one and the last one example 3.333 etc. The next one 0.142857 etc. So that is non-terminating repeating. Now listen, the next type of questions. Show that 0.333 etc. which is equal to 0.3 bar, top of that 3, that bar, can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. So listen carefully, students. This one is non-terminating repeating rationals. We need to express in the form P by Q because it is also a rational number. So the method is, first listen carefully. We can take the first one, x is equal to 0.333 etc. Put equation number 1. Now multiply equation number 1 with a 10 because here one number 3 is repeating. So to change that decimal part 3 into whole number part, we multiply the first one equation with a 10. Now 10 into x become 10x is equal to 10 into 0.333 etc. That is 10 into x, 10x is equal to, when we multiply it with a 10, so one number 3 from the decimal part change to whole number part, that become 3.333 etc. Put equation number 2. Next we need to subtract 2 minus 1, equation number 2 minus 1, that is the left side what, 10x minus 1x is equal to 3.333 etc. minus 0.333 etc. Then 10x minus 1x is equal to 9x is equal to 3.333 etc. minus 0.333 etc. Subtract, that become 9x is equal to 3. Then x is equal to 3 by 9. The lowest form is what? X is equal to 1 by 3. Now we express 0.333 etc. is equal to 1 by 3. Clear? Now the next one, show that 1.272727 etc. which is equal to 1.27 bar can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. Now we can take x is equal to 1.27 bar, which is equal to 1.2727 etc. Okay, so listen carefully. In the first, show that 1.2727 etc. is equal to 1. Top of that 27, that bar. Okay, the above question, the top of that 3, that bar is there. Okay, now listen here, 27 bar is there. Two numbers are what? Repeating, 27, 27 etc. So to change the two numbers to the LHS part or whole number part, we need to multiply with the 100. So 100 into x become 100 into 1.2727 etc. That is 100x is equal to 127.2727 etc. Put equation number 2. Now next to 2 minus 1. 100x minus 1x is equal to what? 127.2727 etc. minus 1.2727 etc. So when you subtract, 99x is equal to 126.000 etc. X is equal to 126 by 99 is equal to 14 by 11. Clear, students? Now the next one, listen. Express the following in the form P by Q, where P and Q are integers and Q not equal to 0. Same type itself. So listen carefully. On all these questions, that bar is, some changes are there. First one, A. So textbook question, this one. You can verify it. Okay. 0.47 bar. Only 7 having bar. Below that, listen. So let x is equal to 0.47 bar. That is 0.477 etc. Put equation number 1. Now after that, we need to multiply equation number 1 with a 10, because the first number 4 we need to change it into whole number part. So 10 into x become what? 10 into 0.477 etc. is 10 into x is equal to 4.77 etc. Put equation number 2. Now 2 minus 1, that is 10x minus 1x is equal to 4.777 etc. minus 0.477 etc. That become what? 9x is equal to 4.3. Then x is equal to 4.3 by 9. Then x is equal to, here to change the decimal point, we need to multiply numerator by 10. So we want to multiply denominator also by 10. So that become what? 4.3 become 4.3 into 10 become 43 by 9 into 10 become 90. That the last answer what? 0.47 bar is equal to 43 by 90. It is the rational number. Clear, students? Good questions and also important. Now the next one, B. 0.001 bar. So listen that below that. Here some correction means that bar. Okay, when we change that into from the lab, when we change it into mobile, some problem is there because of that. Okay, so let x is equal to 0.001 bar, which is equal to 0.001, etc. Put equation number 1. Now, how many decimal places are there? 3. So, to change that decimal part into whole number part, we multiply it with 1000. Then 1000x is equal to 1000 into 0.001, etc. 1000x is equal to 1 point. So when we replace this 3 decimal, repeating one to whole number part, that become into 1000, that become 1.001, etc. Put equation number 2. Now 1000x minus 1x is equal to 1.001, etc. minus 0.001, etc. That is 999. X is equal to 1. So x is equal to 1 by 999. Thus, the decimal format was 0.001 is equal to 1 by 999. Clear, students? Okay, thank you.